Okay. Um, Good evening, everybody. So today I'm going to give a small video lecture about the general stuff about endocrine system. This is gonna be more like physiology than the pathology, but all those info that I'm gonna give you in this lecture is the main part that you should need to understand the endocrine pathology afterwards. So these things are the most important part of the endocrine system. The physiology, how does it work, what's the logic behind the endocrine system. So this is the headline. Actually, there's just one slide which has a lot of inputs step by step. So let's go and build the whole endocrine axis ourselves. Okay, before I go on with the axis, I have to tell you that homeostasis, the word which means the balance of every system in our body, the homeostasis means the balance between the every system in our body. Um, is maintained by two regulation systems, two regulatory systems. And those two regulatory systems are the nervous system and the endocrine system. And endocrine system is much more difficult than neural system as a regulation. So actually, all the endocrine system is made to regulate the functions and to manage the functions of the body, of the different systems, and to arrange the things in a way that everything fits together in the best way. So there's an axis. Actually, both the neural and the endocrine system starts from the CNS, central nervous system, but for the endocrine system, the main guy, the general who controls everything, is the hypothalamus. Now, hypothalamus is located in the center of the CNS, in the what's the thing called? Diencephalon. Um, and actually, hypothalamus has much more functions than just endocrine control. Hypothalamus controls almost everything. It controls the like what's the thing called? Sympathetic, yeah, and parasympathetic neural responses. It controls sleep, um, like water intake, thirst, hunger, sexual drive, a bit of emotions, and so on. So almost everything depends on the hypothalamus. Hypothalamus is your guy who controls everything for you. Everything that is in control in your body and you don't think about it is because hypothalamus thinks about it. Okay? So, and plus there's an endocrine system. So hypothalamus is also in control of endocrine system. But it's not just the endocrine system, it has also like much more pretty important functions to cover. Okay, so hypothalamus controls another gland also in the CNS, just below the hypothalamus, inferior to the hypothalamus, which is called the pituitary gland. And pituitary gland has two parts. Anterior pituitary, which is in yellow in here, and posterior pituitary, which is in green. And pituitary gland also has another name, it's called hypophysis. And the anterior one is called adenohypophysis, and posterior is called the neurohypophysis. Americans usually use the pituitary and the anterior posterior pituitary, but sometimes in Europe you might hear adeno and neurohypophysis. Also, same thing in Georgia. So now let's first state the different hormones that the pituitary gland produces, and then let's do the interaction between the hypothalamus and the pituitary gland. So I'm gonna start with the neurohypophysis and tell you that neurohypophysis um, does not produce any of the glands, any of the hormones. Neurohypophysis does not synthesize those two hormones you see in there. Those two hormones are ADH, so this states for antidiuretic hormone, and oxytocin. But neurohypophysis is just the organ which stores those both hormones. It does not synthesize it itself. Both of them are synthesized in the hypothalamus. They just drain by special pipes, by special draining system to the neurohypophysis or posterior pituitary. They are stored there, and whenever those two hormones are needed, they are excreted from the posterior pituitary. But I'm still gonna tell you one more time, all those two hormones, ADH and oxytocin, are synthesized in the hypothalamus and then carried to the posterior pituitary for storage. Okay. Um, on the other hand, anterior pituitary or adenohypophysis, which is in yellow in here, synthesizes the hormones itself. So it has 6 major hormones, and we're gonna go through all of them. First, prolactin is the hormone which is mainly used for activation of the breast tissue to produce, like, for the growth of the breast tissue and for production of the milk in the breast tissue. So for lactation in the pregnant women and in the nursing women. TSH states for the thyroid stimulating hormone, which obviously stimulates the thyroid gland, and we're going to talk about that later. GH is the growth hormone, because of which we all actually grow in any ways, in height, like width and stuff, size. FSH and LH is united in one like box here, but they are actually two different hormones. Both of them are called together gonadotropic hormones because they stimulate gonads, meaning like ovaries and the testicles. FSH stands for follicle stimulating hormone, and LH stands for luteinizing hormone. We're gonna cover those also. ACTH is the adrenocorticotropic hormone, so the hormone that stimulates the adrenal cortex. And below I have still written there the MSH. MSH is the melanocytic stimulating hormone. The thing is that ACTH and MSH are produced within one protein biochemically. They are encoded, both of them, ACTH and MSH, are encoded in one gene, and post-translational cleavage of the gene cleaves that protein into two pieces, ACTH and MSH. So it doesn't matter which one do you want to produce. If you produce one ACTH, you have to definitely produce one MSH also. They both are co-produced every time. So as I said, ACTH activates adrenal cortex. We're gonna cover that later. MSH is the melanocyte stimulating hormone, so it actually stimulates melanocytes to produce more melanin. That's what happens when some guy's trying to tan or have fun on the beach or something like that. Okay, so ADH, as we already said, is the antidiuretic hormone. Its function is to reabsorb water from the kidney, and water alone, not together with sodium, just the water. And oxytocin is the hormone which functions in different ways, and its functions like are not fully discovered yet, probably, but we know that it functions as the hormone for the contraction of the uterus during the labor, and after the labor, and also oxytocin actually controls the sexual drive, libido, and so on in both genders. Okay, so let's get to the connections between the hypothalamus and the pituitary gland. So, as we said, hypothalamus is the main guy. Hypothalamus controls the pituitary gland. How does the hypothalamus control it? So let's get the hypothalamic hormones now. So there are actually two types of controls: negative control and positive control. So either one hormone will inhibit production of another hormone, or it will activate the production. So in this graph, the red lines will mean or represent the negative control, so the inhibition. The green lines will represent the activation or the positive control. So, okay, dopamine, as you see, blocks the production of prolactin. That's how we actually regulate it. Hypothalamus with dopamine blocks the production of prolactin in pituitary gland. Now, in the TSH way, TRH, so-called thyrotropin releasing hormone, is an activator of the TSH production in the pituitary. So TRH is also a hormone of hypothalamus. Now, GHRH, which stands for growth hormone releasing hormone, is also the hormone of the hypothalamus, which stimulates the production of growth hormone. And there is also an inhibitor hormone of the growth hormone, and that's the somatostatin. Somatostatin is the antagonistic hormone of GHRH, and it inhibits the production of the growth hormone. So actually, for the growth hormone, you got an activation and also the inhibition. For prolactin, you just have the inhibition. For the TSH, you just have the activation. For the FSH and LH, there's a hypothalamic hormone called gonadotropin releasing hormone, as you see, and there is no inhibitor of that. And also CRH is also the hypothalamic hormone, which stands for corticotropin releasing hormone, which activates the production of the ACTH, not the MSH, just the ACTH. But the thing is that if you produce ACTH, you have to produce MSH, as you remember. So that's how it goes. That's how the hypothalamus controls the pituitary gland and its hormones. So there it is. That's the first two levels of the endocrine system. Now we are going to jump to the third and pretty important level: peripheral glands, which are controlled by the pituitary gland's hormones. So all of those prolactin, TSH, GH, FSH, LH, ACTH, all of them control the peripheral glands. So let's go and discuss those peripheral glands. Let's start with the TSH. Before we jump to the TSH, we said that prolactin stimulates the breast tissue to grow and to produce the lactation. Okay, so that's it. Now let's jump to the TSH. TSH, as long as it stands for thyroid stimulating hormone, definitely, as I said, it stimulates the thyroid gland. And the function of the thyroid gland is to produce the T3 and T4 thyroxine. So 3-iodo I forgot the name. 3-iodothyronine and tetraiodothyronine. So actually T3 and T4 is much easier to say. Combined name is thyroxine, and the function of the T3 and the T4 is to regulate the basal metabolic rate in the whole body. So, if I have more T3 and T4 than I need to, my metabolism is extremely increased. So what is metabolism? I actually catabolize everything I have. I use all the energy. I work much faster than I need to. I don't sleep. I don't. I eat a lot because I use up a lot of energy, but I still lose the weight because I still use so much energy that food is not enough, and I'm agitated and so on and so on. I'm very hot actually. So if I have low amount of it, I'm very cold, I'm very drowsy, not energetic at all, I'm gaining weight, I don't want to eat, and so on. So that's what T3 and T4 do. T3 and T4 regulate the basic metabolic rate and are very important in regulation of the homeostasis. Uh, we will discuss the diseases of the thyroid gland when we get to the thyroid. Now, next, growth hormone. What does the growth hormone do? It's pretty easy. Growth hormone um, makes us grow. Grows everything, absolutely everything. Um, so I want you to remember that every organ in our body has the receptor for the growth hormone, and it's insulin-like growth factor. So um, don't think that it only participates in the growth of the bones. It participates in the growth of the bones, muscles, abdominal organs, skin, other organs. Doesn't matter. Everything, absolutely everything. Okay. And okay, let's jump to the FSH and LH. Now, FSH and LH activate the gonads. So I included gonads because I mean both sexes, both genders, activates testicles in males and ovaries in the females, and produces estrogen and progesterone in females and testosterone in the males. So there's also a lot of different types of estrogen, different types of testosterone, and so on and so on. We're gonna also discuss that much in much detail when we get to the gonads themselves and endocrine function of those. Um, and that's it. And ACTH activates the adrenal glands. Adrenal glands, which produce different hormones. Adrenal glands has the cortex and has the medulla. So cortex produces cortisol, aldosterone, and also adrenal cortex produces estrogen, progesterone, testosterone, but in a very small amount. So I haven't included it in here. And the adrenal medulla produces epinephrine and norepinephrine, but the epinephrine is much more important for the endocrine function. Because norepi usually doesn't have the important endocrine function. Norepinephrine is much more important in the neural regulation system. Okay, so ACTH activates cortisol and aldosterone production, but main function of the ACTH is to activate the cortisol production. So aldosterone does depend on ACTH, but not as much as it depends on other things. And cortisol depends on ACTH much more than aldosterone does. Okay? So remember that ACTH produces both cortisol and aldosterone, but cortisol production is one of the main function of the ACTH because aldosterone has its other regulatory systems also. Now, as you see, I have only included the activator arrows, like green arrows. Now I'm gonna include the negative feedback arrows. Bam. So what is the negative feedback? Negative feedback is a very good invention, actually. So imagine that if I control something, and all that system is just to control something, or actually everything, if I produce, for example, if every TSH produces one T3, and I only need 10 T3s to function normally, 10 thyroxines. So I produced 10 TSHs which produce 10 thyroxines, and I feel very good. But for example, thyroid gland just decided to produce even more and produce 20 thyroxines. And now I have the hyperthyroidism. So the thing is that if my T3 or thyroxine level increases, it will block the production of the TSH in the pituitary by the negative feedback. And the logic behind that is that if I already have amount of thyroxine I don't need any more TSH because the TSH will produce even more. So if I have a normal amount of T3, I will block TSH, which will not produce T3 anymore. So I think it's logical. Yeah? Well, okay. Let's move that into other fields. I need 10 cows to feed the population, and I need like special food for cows. So before I grow the cows, I need that food. But after I grow the cows and I have to kill those cows and like feed the population, I don't need that food anymore. So my amount of cows actually suppresses the amount of food. So food activates the cows deactivate the food. TSH activates the T3, T4 production, T3, T4 block the production of the TSH. Okay? Okay, so that's the negative feedback. If I produce something a lot, that something will block me, so I won't produce it anymore. Okay, so almost every hormone functions in that way. Hormones usually have the negative feedback. Okay, so now I don't remember what comes next. Let's see. Oh, okay, aldosterone regulation. Now, if you remember, we did that when we were discussing the blood pressure control, and so let's include the blood pressure in here also. So if my blood pressure drops, there are several systems that's gonna be activated. Renin-angiotensin system will be activated. My kidney will produce renin. Renin will activate angiotensin. Angiotensin will be converted into angiotensin. Like renin will activate angiotensinogen 1. Angiotensinogen 1 will be converted into angiotensinogen 2, which will be converted into angiotensin, and angiotensin will activate aldosterone. So that's what I was talking about. Aldosterone can be activated by the ACTH, but renin-angiotensin aldosterone system is much more important in that. So what aldosterone does, aldosterone reabsorbs sodium in the distal convoluted tubule, and the sodium is followed by water. So actually what aldosterone does, it reabsorbs water by first reabsorbing sodium. That's why I talked about ADH and made you understand that ADH only reabsorbs water, and aldosterone reabsorbs water and also reabsorbs sodium. And that is very important to have both type of hormones, so you can regulate either you can absorb any or only water, or water and sodium. Depends which one you need. Depends if you need sodium or you don't. If you don't need sodium, you're gonna use ADH. If you need sodium, you're gonna use aldosterone. So what about epinephrine? Epinephrine is actually also activated during the low blood pressure, but I include epinephrine for a different reason, because of that reason. There is one more very important organ, endocrine organ in our body, which is not regulated by the endocrine system, like hypothalamus and pituitary axis, and is not regulated actually by the nervous system. It's a very autonomic organ, and it is only regulated by the amount of sugar or the glucose in the blood. So it's the pancreas, endocrine pancreas, and its two main hormones, insulin and glucagon. Now, why did I include it here? Because I want you to understand that insulin is a very cool guy, and he is all alone and functions all alone. Insulin versus glucagon, cortisol, epinephrine, growth hormone. So imagine there is one insulin on one side of the function, and on the other side of the function there is glucagon, there is cortisol, there is epinephrine, and there is growth hormone. All of them doing the same thing. And so, one more time, insulin versus cortisol, epinephrine, glucagon, growth hormone. Growth hormone is the least important in those. So, okay, if I had a very good meal and my blood sugar level is very high, I produce insulin, which does several things. Insulin drives the glucose into my cells, so my cells now have the glucose to eat. And also, insulin converts glucose into glycogen in the liver and muscles, so I have something to store. I store energy, I store glucose in the way of storing glycogen in my muscles and the liver. Whenever my blood sugar level goes down, I produce glucagon, which does the opposite thing, converts the stored glycogen to glucose, and then glucose is used up by the cells. So now imagine, okay, that is logical, okay, that's logical, but why cortisol, why epinephrine, why growth hormone? Because when do I have the epinephrine activation? When I'm nervous, when I have the sympathetic activation, when I have to run, when I'm chased by dinosaur, or when I'm, I don't know, in a war, in a fight, I don't know, something. So something, an activation of the sympathetic system is a stressful activation. What happens during that? I'm getting ready for a fighting response. So if I'm getting ready to the fighting response, I will definitely need muscles to fight. You cannot fight by ice or skin. You need muscles to fight. And what do the muscles need? Muscles need energy to fight. Where do you get energy from? Glucose. Where do you get glucose from? Glycogen. Who converts glycogen to glucose? Glucagon. Okay? Glucagon, epinephrine, cortisol. So that's why I need epinephrine. That's why epinephrine converts glycogen into glucose, because I need glucose in a fight and flight function during the sympathetic activation. Also, any kind of stress, doesn't matter if it's physical, psychological, blah blah logical, I don't know, any type of stress produces cortisol. And during stress, you need energy. In the same manner, when during the sympathetic activation, you need energy. So cortisol also produces high blood glucose level. So that's why there's insulin on one side who stores and uses up the glucose, and on the other side there is cortisol, epinephrine, glucagon, growth hormone, which act counter to the insulin. Okay? Okay. I haven't talked about parathyroid glands, which is absolutely different field, and the calcium metabolism, absolutely different field. So we're gonna cover it in a different lecture. So this thing that you're looking at now, remember that, realize that, understand this, and the endocrine system will be extremely easy for you. If you don't understand this graph, then the endocrine system pathology will be a disaster and a nightmare for you. Okay, so this is the main thing. So thanks a lot. If you guys will have any questions, we can talk tomorrow and the day after tomorrow on the seminars. And I'm gonna ask you to read or at least watch the pituitary gland pathology, which is extremely easy because I can talk about it in 2 minutes. Because pituitary gland can either produce more or less hormone. It can produce more prolactin, less prolactin, more TSH, less TSH, more growth hormone, less growth hormone, more FSH, more and LH and less FSH and LH, more ACTH, less ACTH, more ADH, less ADH, more oxytocin, less oxytocin. It's easy. You produce more TSH, you will have more T3, T4. You produce less TSH, you'll have less T3, T4. You produce more growth hormone, you will grow more. You produce less growth hormone, you will grow less. And so on and so on. It's extremely easy. We're gonna discuss that much better, but I want you to read or at least watch the Kaplan videos for the pituitary gland pathology, because we are going to discuss it tomorrow and the day after tomorrow in class. Thank you very much. Enjoy your night, probably, or something. Goodbye.